We're going to take a look at a demo program which is going to tell us whether a two-dimensional matrix is a scalar matrix or not. So what I have defined here is an array A containing 5 rows and 5 columns. I require two variables I and j to index through a two-dimensional array. I is for rows, j is to travel through the columns. And we'll understand m is the upper limit for the number of rows, n is the upper limit for the number of columns. So although I have said 5 rows and 5 columns, the user may just enter 3 rows and 3 columns. Then what I am going to do here is I have defined a variable called as a scalar. This is going to have an initial value of 1 or whatever it is. It could be even -1. The minute when I'm doing it, if an array doesn't turn out to be scalar, I make this value 0 and then I tell the array is not scalar. Scalar element is a variable which is going to contain the value of a of 0 0. That means it's going to contain 0th row 0 element because that is the diagonal. So all the diagonal elements should be equal to the scalar element, then only it's a scalar matrix. So first is I am asking the user to enter the order of the matrix. So let's say the user enters m rows and n columns. Both could be same. That's how only we can end up doing a check on whether it's a scalar matrix or not. Then using this for loop, a combination of for loops, I am going to read values into this matrix using I for row and j for column. So this particular thing will loop again and again till the values of a of ij are entered. That means as long as I is less than number of rows and j is less than number of columns, it will keep accepting those values into the array. Now let's take a look at the logic to do this particular thing. So I am assuming the number of rows are equal to the number of columns. Then only I'll be able to do this particular logic. So first thing what I am doing here is I am making scalar, this variable called as scalar is equal to 1. And at the same time scalar element I am making it equal to a of 0 and 0. That means this is the principal diagonal element. So all the elements along this diagonal should have the same value and then only it's a scalar matrix. So once I have done this, it's quite simple. I am going to be using two loops so that I am able to travel through the rows and columns properly. I less than m and I plus plus. Similarly, for j is equal to 0, then j less than the number of columns, j plus plus. All right. Now what I'm going to do for this is I'm going to compare the value of I and j. That means when I is equal to j, that means we are along the diagonal. If we are along the diagonal, all right, and if I equal to j, I'm going into this box. If a of I j, since I is equal to j, I could also have said a of ii or a of jj, but it's okay, is equal to is not equal to scalar element. Okay, if it is not equal to scalar scalar element, I am going to do this following activity. I am going to set this scalar variable to 0 and then I am going to do a break out of this particular loop. All right, I'm going to do a break out of this particular fellow. Now else, what can be the other possibility? The other possibility can be like this. Else, okay, the other possibility can be if a of ij, okay, is not equal to 0. So I'm going to say else, I'm going to have a bracket in here. If a of I and j is not equal to 0, all the other elements for a scalar matrix should be 0. So if this condition is also true, then I'm going to make scalar equal to 0 and then I'm going to do a break. All right, sorry, I'm going to do a break. And this is the else, this ends the else. Then I believe I have covered the loop adequately. So this way what I have done is I have one break here, I have for the else, And then do I need anything for the, yeah, I need one for this if here. I have a if statement if m equal to n. So this bracket should be ended here. So it's missing one bracket. So I put this particular thing here. Then after this, I have already typed a little bit. If the scalar remains 1, then I'm going to say the matrix is scalar. Otherwise, I'm going to say it's a non-scalar matrix and close the program. So let me try to explain this particular loop for you. Assuming the number of rows is equal to the number of columns, I am taking a variable also known as a flag variable with the initial value 1. I am taking the 0th row, 0th element equal to the scalar element. I am going through the rows through I, going through the columns through j. When the value of I is equal to j, it indicates I am on the diagonal element. If the diagonal element is not equal to the scalar element, okay, then I am going to make this particular variable 0 and break out of the loop. Else, if a of ij is not equal to 0, that means any other number other than the diagonal element must be 0. If it is not, I am making scalar 0 and breaking out of this loop. So this is the end of this if and for loops. And now I'm going to just compare whether it's a scalar element, then I'm going to print scalar matrix, or I'm going to print not scalar matrix based on the value of scalar. Let's first try to compile. It's a long program. I could have made compilation mistakes. Okay, as usual, nothing new. Okay, all right, I missed a bracket probably. Okay, that's not a problem. That's typing error. Then let's save this and compile again. So all the errors go out. Sometimes one error can give you multiple errors. So just try to eliminate them and then try to run it. Enter the order. I'm going to enter a 3 into 3 matrix. Okay, so what I'm going to do here is I'm going to enter -1, 0, 0. Then next is going to be 0, -1, 0. Then what I'm going to do? I'm going to enter 0, 0 and -1. So this should be an example of a scalar matrix. So it says it's a scalar matrix. Now what I'm going to do here is I am going to rerun it, and I'm not going to enter a scalar matrix. I'm going to enter a 3 into 3. But this time what I'm going to do is I'm going to enter -1, 0, 0. Okay. So this is okay. This is again 0, -1, 0. So far it's good. But I'll make a mistake at the last thing. It will be 0, 0 and -2. So it should say this is not a scalar matrix. So it's saying non-scalar matrix. So that's all. This program is quite simple as long as you understand two parts to this. The first part you should understand is be sure you take this variable scalar, make it 1. The minute it's a non-scalar, it will become 0 here, as in this case here, as this cursor is moving, and you will break out. Similarly, if the non-diagonal elements other than the principal diagonal elements, if they happen to be not equal to 0, you will make scalar 0 and break. And the second thing you need to remember is the 0th element, that is 0th row and 0th column element, that is the first element in the diagonal, you should give it the value of scalar element, because every element along the diagonal should match the scalar element. If it doesn't match, then something is not right and we have failed in doing the scalar test properly. So if number of rows is equal to number of columns, then only I am doing this. Only a square matrix you can find a scalar matrix. Otherwise rest you can say it's a non-square or a rectangular matrix.